Hi there, geometry friends, and welcome to the Unit 11 Day 1 notes. Yes, we're learning things. We're so excited about it. Actually, the first thing that you're going to see in our notes today is just a bunch of formulas. So nothing really to write down, just different things that we're going to be using throughout class today. And then down below, you'll see a bunch of example problems. Most of these are really straightforward. You're just plugging into formulas. Like, we all know how to find the area of a square, but if we've forgotten, just look up top. The only thing that I wanted to mention on this page is just that you're going to need to be very careful about triangles. Our area formula for triangle is 1/2 base times height. And for this right triangle, it's totally cool and fun to call this 60 the base and this 50 the height. But take a look down here at number 3. A couple different ways that you could attack this problem, but one way that you might start is by calling 10b, and then this line that I'm making orange is our height. Now, 13 is not our height. That's just a side length of this triangle. So think about how you might find out what x is. If you said Pythagorean theorem, then you win. So maybe off to the side, I would do 5 squared plus x squared equals 13 squared. Solve that up. There's going to be my height. And then I can plug into area equals 1/2 base times height. So what I'm going to ask you to do is pause the video, try these 6 problems, and then I'm going to put the answers up. Uh-oh, there's Miss Taylor. And then I'm going to put the answers up and you can check your work. Okay, so now you can go ahead and unpause the video and let's check our answers. One thing I forgot to mention before was that we want to be putting units on our answers. So for instance, when we have a square that has a side of 8 centimeters, 8 times 8 gives us 64 squared centimeters. So try to include those units. The triangle in number 2, we should get 1,500 feet squared. The triangle in number 3, let's see, we would do 1/2 10 times our height of 12, and that's going to end up being 60 inches squared. Our trapezoid, 6, this is our height, this 6 is our base, this 10 is our other base, so let's see, 16 times 3, 48 centimeters squared. And then down the bottom, number 5, we're going to go over that one together when I come back, because there's a bunch of different ways you can do it, and I want to see all the different creative ideas you guys come up with. Then number 6, the rhombus. This is the only formula that isn't going to be on the official SOL formula sheet that you would get to use on your test. So this would be maybe the one that you would write down immediately once you get that assessment. When I multiply everything out, 90 meters squared. So those are kind of the easy problems we're going to see today, and we're going to move on now to some of the harder ones. This is when we're working backwards from the formulas that we've got. So for example, in number 1, it says that the area of a square is 81 centimeters squared. Find the measure of the side length. Something that I think is really helpful is if you start by just writing down the formula you're using. So when I read area of a square, I write down area equals, and then I go over to my formula sheet, look up what that area is if I've forgotten. The area is side squared. So if they're telling me the area is 81, then where I see this letter A, I'm going to put an 81 instead. And then S is what I'm solving or what I'm looking for. And right now I don't have S all by itself. I've got this annoying little 2 sitting up top there. So I'm thinking, how do I undo squared, or how do I get rid of that little 2? And hopefully the answer I come up with is my BFF square root. So I'm going to square root both sides. Square rooting and squaring are inverse functions. They undo each other. So that would get me S all alone, and the square root of 81 is 9. Now, the side is a one-dimensional length, meaning when I consider my units, it's not going to be centimeters squared, it's going to be just regular old centimeters. Cool. Once I know how long the side is, I can use that 9 in maybe a different formula or in a different way. So when I read part B, it says, what is the perimeter of the square? I'm thinking about, oh, perimeter means the distance all the way around. And you can also draw a picture to kind of help you out. So a square would be 9 inches, or sorry, 9 centimeters on each side. So if I need to find my perimeter, I'm just adding all those sides up, or since they're all the same, doing 9 times 4 to get 36. And perimeter, it's a distance, it's a length, so it's also going to be a one-dimensional measurement in terms of our units. Alright, so we'll look at, I've got 2 more examples and then I'm going to set you guys free to work. When we look at number 2, it says the area of a trapezoid is 112 meters squared, the height is 8 meters, the shorter base is 12 meters, find the length of the longer base. So once again, the place where I'm going to start is by reading trapezoid area. So I'm going to go look at my formula sheet, write down that formula. I'm going to plug in what I know and solve for what I don't. So they're telling me the area is 112. So wherever I see A, I'm going to put 112. They're telling me the height is 8. So wherever I see this H, I'm going to put an 8 instead. And then the shorter base is 12, find the length of the longer base. So I know one of them is a 12, the other one I'm going to call X. And now I've got to solve this thing. And I'm looking at it and I'm like, oh, this is gross. Let's see if there's any simplifying I can do before I start trying to move things away from that X. So like, for instance, what I'm about to circle in maroon, this 1/2 times 8, those are both numbers, so I can simplify that. I know that 1/2 times 8 is 4. So I'm going to simplify that expression a little bit. And then in the parentheses, I've still got 12 plus X. Now, a lot of you might be tempted to use the distributive property, and that would be fine. But my goal is to get stuff away from this X, not put more stuff next to it. Distributive property would give me a 4X. So actually what I'm going to do is divide both sides by 4. And 112 divided by 4 is 28. So now I've got 28 equals 12 plus X. That's one of the fun, easy problems that we love. When I subtract 12 from both sides, I would get that X is 16 meters. And if you're doubting your answer, not really sure, remember that you could always take all these measurements, the bases, the height, and plug them back into the original trapezoid formula and make sure that you get 112 as an answer. Alright, so the very last kind of thing we're going to see is when we're given irregular shapes, so something that isn't just a square or just a circle, where we're kind of combining more than one shape to see how much this shaded area is. So for instance, when I look at number 5, I see this big rectangle and then a small rectangle inside of it. And one thing that I think is really helpful is to draw sort of a map of what I'm doing. So I've got like this big 8 by 10 rectangle and it's all shaded in. If I want just the shaded area, I would subtract out the little white rectangle in the middle. So this little rectangle has dimensions of 5 by 8. And then when I've drawn this little map, it really helps me kind of conceptualize what's going on. And the area of the big rectangle, 10 times 8, is 80. The area of the little one, 5 times 8, is 40. And when I subtract 40 from 80, I would figure out the area of just the shaded region, which is 40 square feet. We're back to figuring out what area is, so we'll be dealing with things in 2 dimensions. And the last problem that we're going to look at is number 6. So first of all, I'm going to draw myself a little map. I see a square is kind of like the outer shape. And then I see this semicircle as my inner shape. So square minus semicircle. And then I'm going to think about how do I find the area of both of those things, what formulas am I using. So for my square, it's side times side, or side squared. So the outside shape has an area of 16. There aren't any units here, so it's okay to just put the number. Now, with the semicircle, you may want to write down the formula first. Pi r squared would be a whole entire circle, but I don't want a whole entire circle, I just want half of it. So I'm going to have to divide that pi r squared by 2. And then I need to think about what needs to get plugged into that formula. In this case, it's the radius. So imagine with me that this line that I'm making green, this side is 4. Think about how much the radius would be. Hopefully you said the radius just this side would be 2. And one thing that I'm going to allow you guys to do is leave your answers in terms of pi. So as soon as you've got 16 minus, and you simplify this up a little bit, let's see, 4 squared, or sorry, 2 squared is 4, divided by 4 is 1. So this would simplify up to be, oh my gosh. I need to recognize the error of my ways. Somehow this magically became a 4. What in the world? Oh. Pi r squared divided by 2. Sorry, copy error. Let's see, so 2 squared is 4. This fraction is going to end up looking like 4 pi in the top, 2 in the bottom. 4 divided by 2 is 2. And then I'll just write the pi right there next to it. And it's okay to leave your final answer just like that. So what I would want you to do now is try the 2 problems down here at the bottom, number 7 and number 8. If you had something that was confusing to you today, talk to your neighbor about it, see what you guys can figure out together, and if you still are stuck, write it down and be ready to ask me when you see me next week. And once you're done with those couple problems, looking over your notes, this practice, starting on the next page, I think the pages are numbered. Yeah, this practice started on page number 3 and continued on to page number 4. That's your task for class today. Our lovely substitute, give her a round of applause, has an answer key. So if there's one question that's stumping you, you can always check there. And I hope you guys have a really great Memorial Day weekend. I'll see you soon.